Special right triangles, which we just covered, is a branch of trigonometry. Because what I mean by that is when you're looking for a side, just like with special right triangles, you're going to be given one side and one angle. That's what they're going to start you off with. The difference being that with special right triangles, that one angle that they gave you was either that one angle that you were given to start with was either, well, all of these are going to be, they're going to have a 90 because we're either 30, 45, or 60. Yes, they're all going to have a 90. We're still dealing with right triangles. When you take the test, it's all going to be on right triangles when you come back. Now, at least, you know, if you get around to looking at your quiz grade and you don't like what you see, you know, you still have the ability for the replacement, which actually coincidentally I forgot to do for the parallelograms. You know that if you do better on the test than on the quiz, we do grade replacement. So I did that yesterday. It shouldn't make a big difference, but if you saw your grade change by like a percentage point, it would have only gone up. It wouldn't have gone down. If you did better on the parallelograms test than on the parallelograms quiz, I went back and changed it yesterday. I just forgot to do it the first time around. But that'll be available here as well. So when that one angle is 30, 45, or 60, that allows us to be exact, which is why we had exact conversions. Times square root of 2, you know, divided by square root of 3. We had exact conversions, so we didn't have to round. When that one angle ends up not being 30, 60, or 45, then we have to use a calculator, which means we're going to round. Be prepared to round. Mucho rounding. Okay. That means a lot of rounding. All right, so here's a right triangle. Right triangle has two legs and a hypotenuse. It has one 90-degree angle and then two other angles that are complementary to that. So here the angles are denoted by capital letters and the side lengths are denoted by lowercase letters. Years from now, whenever somebody asks you if you've ever learned anything about trigonometry, there's two main types of trigonometry. We're dealing with right triangle trigonometry, which is what's covered in geometry. And then if you ever make it to Algebra 2, Pre-Cal, and so forth, then you start getting into coordinate trigonometry, where you start learning how to do it on a coordinate plane. The main difference is what the angles are allowed to be. If you're in a right triangle and 90 degrees are being swallowed up by the right angle, how many degrees do you have left? How many degrees do you? 90. You have 90 left, meaning you in right triangle trig, no angle can be greater than 90, and obviously no angle can be less than 0. Once you get into coordinate trigonometry, you can have negative angles. You can have angles be thousands of degrees. You get into a new measurement for angles. You start learning about that angles can be measured also in a unit called radians instead of degrees. But this keeps it pretty simple. Anyways, the point I was trying to make is that years from now, when they ask you, hey, have you learned anything? Well, you might say no, but those of you that say yes, this is what you're going to remember. It's a little phrase. You may have heard it already. It sounds like suck a toe. What? The way you remember it is because it sounds like suck a toe. As tempting as... You might want to keep that to yourself. But so I told you what the lesson is going to consist of. Something that's not part of the lesson is how to take off a hood after your teacher asks you to do it over and over again. That's just kind of implied. But then half of it is a calculator. The other half is knowing how to set up a trig equation. This allows you to remember how to set up a trig equation. The first trig function is known as sine. When you look at it on your calculator, it looks like sin, but it's pronounced sine, and it's even spelled sine, S-I-N-E. It's the key that says S-I-N. And then what the so part in SOHCAHTOA reminds you, Bazit, it's nice that you're awake, but can we like actually look here? Appreciate it. We're gonna have okay, you know how for special right triangles we use words like short leg, long leg, just regular leg? Well, all right, there's gonna be new trig words. The hypotenuse is still gonna be the hypotenuse. We're still gonna refer to that as a hypotenuse. That's still gonna be across from the 90. But as far as the legs go, instead of referring to them as short leg or long leg, we're gonna use words like opposite or adjacent. And those can change. It depends on what angle we're referring to. So when you take a trig function, you're taking it of an angle. You take the sine of an angle. You take the cosine of an angle. So depending on what angle, like let's say I'm going to take the sine of B. Okay, that's the angle I'm referring to. The two words that we're going to use are opposite and adjacent. Opposite leg and adjacent leg. Which leg is opposite of the capital B? What is across from? What leg is opposite? Opposite. What is the one side in the triangle that does not touch? Yeah, the little b. So that would be the opposite leg in this case, which would mean that A would be the adjacent leg. It's the leg that it touches. C is always going to be the hypotenuse because that, well, I mean, it's not always going to be called C, but it's the hypotenuse is always across from the 90 no matter what. If we are referring to angle A, which leg is opposite of angle A? The little a, yeah. And what leg is adjacent? So make sure you learn those words. We use those words for trig. For a special right triangle, we use the different words like leg, short leg, long leg. Anyway, so sine is going to be the opposite over the hypotenuse. Yes? Don't focus on the letters. This is just one example that I gave you, and I happen to use those letters. Okay? Yeah, the little letters are representing lengths. So yes, you would see numbers in those places. Yes. Okay. What you need to understand is there's two legs in a right triangle. One of the legs will be touching that angle. One of the legs won't be. The leg that's not touching that angle is the opposite one. The leg that is touching it is the adjacent. But that switches if you switch angles. The one angle that you're never going to take a trig function of is the 90. It's always going to be one of the other two. Yeah. Let's start the examples, and I think you're gonna like just try to stay with me during this, and then because I think what you're struggling with is the abstractness of this, the fact that there aren't any numbers, so it's confusing you. But I'm just trying to put down some concepts. Okay. So when I ask you what the SO stands for in SOHCAHTOA, it is opposite over adjacent. When you start writing trig equations, this is a trig equation, this is a trig equation, you're going to have a, here watch, I've even had some success before teaching it this way. Like literally, you're going to like fill in the box. This is the way a trig equation is going to look. Here's a box, here's a box, here's an equal sign, here's a fraction bar, here's a box, here's a box. What goes in the first box? A trig function. Either sine, cosine, or tangent. What goes in the second box? Always an angle. And then in these two boxes are sides. So what this reminds you, the SO and SOHCAHTOA reminds you that when you're using sine, when sine is the function that you're using, on the other side of that equal sign, the side that goes on top would be the opposite, and the side that goes on the bottom would be hypotenuse. The sequence is important. It is opposite over hypotenuse. If you are ever being asked to use cosine, the ka in SOHCAHTOA means adjacent over hypotenuse. Adjacent on top, hypotenuse on the bottom. And the TOA in SOHCAHTOA tells you that tangent, which on the calculator is tan, is opposite over adjacent. And for those of you looking for complaints, hey, look, this so far all of these notes have been written in your teacher's handwriting. Go figure. So there should be no reason not to learn this, because if you write it, if it's in the teacher's handwriting, then it makes sense. Unless you can't read it, that's true. Well, the good news is if you can't read it, I've also included a graphic that tells you the exact same thing. There's nothing different here. This is the exact same thing, but it's just not in the teacher's handwriting. Charisma, 2 cents? No. So this is the exact same information I just gave you above. Right, Kenny? Now, this is the last important part of this page. Everything I've shown you so far is how to find the missing side. And that's what you're used to with Pythagorean theorem. That's what you're used to with special right triangles. And the majority of the stuff in trig is going to be to find a missing side also. But trig can also be used to find missing angles. Right now, the only way you know how to find a missing angle in a triangle is if they give you the other two. Because how many degrees are there in a triangle? It's just 180. So if they give you two of them, you subtract them, and whatever's left over is that third missing angle. But trig can be used on right triangles. It can be used on right triangles where if they give you, now instead of giving you an angle, now if they just give you two sides, meaning the only angle you know is the 90, you can use trig to find missing angles. So what I want you to focus on is this little -1 that looks like an exponent. That's called an inverse. So and on the calculator, you tend to find those right above the sign. Like inverse sign is right above sign usually. You just gotta hit like shift, or second. Inverse cosine is right above cosine. Inverse tangent is right above tangent. But understand that these are used to find angles. Regular trig functions are used to find sides. Inverse trig functions are used to find angles. So you have to know what it is that you're looking for. I added another graphic here, but this is just more for reference purposes. If it comes up later on, we're not doing any area right now, but trig functions can also be used to find area of a triangle. I just threw it in there for free. It's Friday free for all. But I'm not gonna really spend any time on this now. If you need it later, we will, but you won't be asked to find area. But you can use it, and specifically the one of all of these, the one that's used to find area is sine. You could use sine to find the area of any triangle. It doesn't even have to be a right triangle. It could be any triangle. Maybe we'll revisit that when we get to the area unit. I know Kenny will. Kenny, what do you like better, area or volume? Neither. I said that. All right, so let's get to the examples. Ignore the red part. That's just the answer. The red part is not part of the problem. That's just the answer. Scratch it off if you want. It's just that I copied this problem from a teacher's edition, so the answer comes out there. So this is a trig equation. It has already been written for you. So, as far as skill-wise, yeah, these are the greatest ones because you don't have to write it. And where it gets a little bit more, not hard, but where it gets a little more challenging is when they give you a diagram and you have to interpret the diagram and write your own one of these. But if we break it down piece by piece, notice how we can recognize you have a trig function. The 40 is an angle, good, that comes next. Because you're going to have to eventually write these on your own, which means the x is a side. Which side is the x? If we're doing sine and we learn so katoa, that would be, if I could see a picture, that x would be opposite of the 40. It would be across from it. It would be the opposite leg. What you mean at the 18 is the very good. Look at that. Okay. So it's just that it's been written 40. First, I need you to understand the different components of a trig equation, because eventually you're going to have to write these on your own. You're going to have to substitute. You look at a diagram, identify, and substitute. Huh? Mm-hmm. Mm-hmm. Yep. Yep. But depending on the function, you have to know where to put the sides. Oh yeah. Because eventually you're going to just be given a diagram, and now you have to write it yourself. Okay. Not many things are implied nowadays. You can't assume things are implied. Anywho, so here comes the solving part, right? So I can make this really, really mathy, okay? Or I can try to make it really simple for you. See? Now, I tried the same thing with special right triangles. I tried to make it simple for you, like with the dividing of radicals. That involves something called rationalizing the denominator. And go figure, in a geometry meeting that came up, and pretty much the universal consensus with all teachers was that their students didn't know how to rationalize denominators. Okay, which is something you should have learned in Algebra 1, but then the teachers were saying that, we spend a very small amount of time on that. It's the beginning of the year, so maybe that's why kids don't remember. Anyways, long story short, I tried to give you a shortcut for special right triangles. Didn't seem to work too well. For some people it did, but not for enough. For Muhammad it worked for, so that's good. So here's the shortcut. Here's the best I could offer you. If you don't want to get real mathy and learning how to isolate a variable and stuff, and you just want it simple, look at what I'm solving for. I'm solving for a side, right? Regardless of the trig function we're using, because the only difference here is going to be what button you push on the calculator. It doesn't matter if it's sine, cosine, or tangent. Is that x on the top or on the bottom? Okay. When the x is on the top, you are going to multiply. And the way you're going to multiply is you just get whatever's on the bottom and move it to the front. So I can just say x is equal to 18 sine 40. But wait, there's more. Another thing you have to make sure of is that your calculator is set to the correct unit. Because I told you with trig, there's not only are you pressing buttons you've never used before, but there's different units for angles that you've never heard of. Okay, the main one being radians. Now the good news is that most calculators by default are set to measure angles in degrees. But sometimes you guys hit buttons that you don't realize, the calculator's in your book bag and it gets hit around and you don't realize it, but your calculator is no longer measuring angles in degrees. So what you want to make sure is that you either have like a D on the display or like a DEG, it depends on the brand name. If you're not even sure that if your calculator has a reset option, reset it, because it is the default for most calculators. Does anybody not see a D or a DEG like actually on the screen, permanently on the screen? Because that tells you that you're measuring. Okay, you're measuring. Yeah. Those usually have a button in the back. There's no button. All right, so look. Yes, ma'am. If you don't want to reset it, I'll sit down. Go to mode. They have using gradient. It's true. Now the good news is most of you have calculators with multi-line displays, meaning when you turn them on, they blink at you. So on those types of calculators, it's kind of more like a computer where you can type it as you see it. Where I was from before, the calculators that were predominantly used were single line displays, so it got a little tricky. But you guys should be able to now just type in 18 sine 40, and then the important thing is that your calculator it's going to be rounding. Trig is all about rounding. So you should be getting approximately 11.57 according to what's up there. Just type in 18 sine 40 equals. See, yeah, these are the ones. If your calculator has a single line display like this, it's a little bit tricky because you have to hit it backwards. So you gotta go 40, 49, and then hit 9. Yes. That means you're probably in radians. So hence when I went to show other 400 people how to switch it. Mode. Radian. Yeah, it looks like maybe if you have a graphic calculator, the default there might be degree.
Wait, so I said it's a degree?
Yes. Did anybody else not get 11.57 approximately? There's going to be rounding involved. There's always going to be rounding trick. Okay, let's do another one. Look at the question marks here. Here, they're not asking you for a missing side. What they want here is the entire fraction. They don't even give you any measurements. So all they want here is to make sure that you know how to identify the appropriate side. So what is the angle that we're referring to in all of these? Angle A. So we're going to go look at angle A only. And first let's answer the sine of A. What is sine a ratio of? What's the SO in SOHCAHTOA? Opposite over. Which side is, what leg is opposite of angle A? S. So there should be S over. What is the hypotenuse here? T. They're not asking you to find the side. The question mark is the entire fraction. All they want to know is what's the fraction. Yes. The next thing they're asking me for is cosine. So here we go. We're at the same angle A. What is cosine? It's adjacent over hypotenuse to Tanya. What leg is adjacent to angle A? What of the two legs? What is the only leg that is touching angle A? Well, it wouldn't be T because T is the hypotenuse. Leg, opposite leg, it would be R. And the hypotenuse is adjacent over hypotenuse. And then the last thing this question is asking for is the tangent. What's the TOA in SOHCAHTOA stand for? Opposite on top, adjacent on the bottom. What leg, opposite and adjacent go with legs? S is opposite over what's the adjacent? And then all the children redo it. We have just written all the trig. Everything is building up to you being able to write your own trig equation. Especially Bazzi. Yes, Natalie. What? You found the missing side. Remember, this is side over side. Like we went over. She was asking about this last question that we found. And I guess it's a good question. Is well, okay, yeah, x is 11.57. What the heck does that mean? Okay, so we went over and we said, hey, that's the function. That's an angle. And then both of these stand for sides, right? And because we were doing sine, what's the side that goes on the top on sine? No, the opposite leg. So even though we can't actually see a picture of this triangle, if we could see a picture of this, If we could see a picture of this triangle, and we were to be like, oh, this is 40 degrees here, then what we found was whatever side that was, and what they were telling us is that the hypotenuse, that's what a diagram would look like. It's just they didn't give us a diagram. Ooh, what? They keep on changing things around. I don't like this. Where's the variable here? But where is it located? This is another trig equation. This is a trig equation. The only difference is, well, I don't see a fraction. Well, how would you write 0.5 as a fraction? 1/2. So they just decided to write it as a decimal. What could he do? What I care more about is where is the variable? Where is the letter? The angle. Very good. It's the angle. So here they want you to find an angle. And in order to find an angle, what do we need to use? Yes, shout it from the mountaintops. The inverse. The inverse of what? The function that's already there. So the easy way to do it without getting too mathy is to say this A that I'm looking for is equal to, if they're giving me sign, use inverse sign. Gotta find the button. Inverse sign of what? 0.5. What are we looking for here? So when Natalie asks, like, what are we looking for? What are we looking for? We're looking for an angle. They're going to give us one of the angles. Well, what'd you get? 30? So this would be 30 degrees. We just found an angle, 30 degrees. Aziz found it too. If you want, he'll lend it to you for the weekend. But then you got to give it back to him. How did you have to use the inverse sign button?
I don't know how to say.
Are you there? Correct. Yeah, this is something that other than with special rights, see, it just happened to be that, look at the angle that you got. Wasn't this one of the angles from the special right triangle? 30, 45, or 60. So maybe this could be done in your head. But for the majority of stuff with trig, it's just, whoever, I don't know which type of mathematician invented trigonometry. You'd have to go back a real long time. But whoever did, just realize, geez, when you have different sized triangles, even though the sizes of the triangles might be changing, if you look at the way that an angle, like let's say this was like 26 degrees, relates to a ratio of the sides. So like even if a triangle gets bigger, well, if one side is getting bigger, they're all getting bigger. So a ratio, division, if you divide them, geez, every time I had a 26-degree angle and I divided, whatever, opposite with hypotenuse or opposite with adjacent, I keep on getting the same thing. Gee, that's weird. And, how do they program calculators? No, I don't know how they program a calculator to get it. But yeah, the fact is that the decimals are irrational. They go on forever. So I don't know how they program the calculator to know it. Yeah. No, I get it. But the only thing I would know how to explain to you is what the calculator is finding. How the calculator is programmed to find it, I don't know how they program it. Yeah. But what it's finding is saying, hey, if I were to get this 26, this and obviously if this is the right triangle and one of the angles is 26, the missing angle would be what? 64? 56. No, 54. What is this? 180. No, 64. Yeah, because 90 and 90, yeah, 64. Sorry, I was right the first time. 64. So look, even if I make this triangle bigger, even if I were to make this bigger, yeah, the individual sides are getting bigger, but if I divide any two sides, I'm still going to get the same number because they're all getting bigger. And that's where trig comes from. Typically on most calculators, it's right above that operation. So you know where the sign button is?
Press the second.
Yay, we're going to write our first trig equation. Yay! happy Friday, yes?
No.
Because that's where it was located. I gave you like a template. That's a good word to use. I gave you like a template for a trig equation. I told you in a trig equation, you're gonna have like 4 key spots. One is the trig function, which either be a sine, a cosine, or a tangent. Then right after that always comes an angle. Then you have some type of a side and some type of a side depending on the trig function. Where was the variable? Where was the unknown located here? Yeah, right where the angle goes. But that's fine because look, even if you're having a little trouble getting it, this is the perfect time to understand it because it's the first time we're going to write our own. Okay? So in order to be able to write your own, and look, and this is a nice one to start with because this is also a special right triangle. So we actually should be able to know. Here, watch. Let's do it first as a special right triangle just to see if we get the same thing. Okay? This is a 30, 60, 90. Sure. And what side are they giving you? The short leg. Yeah, they're giving you the short leg. They want the long leg. So really, I know off here to the side that I should get 20 square root of 3. 20 times square root of 3. If somebody put in their calculator what 20 times square root of 3 is, it tells me up here it should be around 35, but
34.6.
okay, so yeah, they just run it to the nearest whole number. But it's around 35, right? It just happens to be by coincidence that the one angle that they're giving me is one of the 3 angles for special right triangles. So I'm trying to tie in what we already know to what we're learning now. I don't want you to do this by special right triangle today. You're seldom going to be able to do this by special right triangle, but I want to tie it in so that you understand that it works. Okay, now let's do this by trig, which is the way that we're supposed to do this. Okay, in order to figure out what we know the angle. The angle that we're going to use is 30. That we know. Okay, you don't need to draw boxes, but just so that you kind of visualize. I need to know what trig function to put, and I need to know which sides to put. Now I know the sides because of the sides they're giving me. One of them is a 20 and one of them is an 8. But I don't know where to put the 20 and where to put the 8. That's going to depend on the trig function. So let's figure out the side they're giving us and the side that we're looking for. Based on the location of the 30-degree angle, what side are they giving me? Opposite leg. What's opposite legs? Let's start using better words. Opposite leg. What side? Bless you. They're giving you the adjacent leg. Sorry, they're looking for the adjacent leg. Okay, so the question is, what trig function relates opposite leg and adjacent leg? Tangent, very good. So that tells me I'm going to write tangent in front of the trig. That is also on the calculator, yes. There's actually, eventually you'll learn that there's actually 6 trig functions, but these are the main ones. Yeah. Okay. Then I need to know what goes on the other side. Well, because tangent is specifically opposite over adjacent, which one was the opposite? 20, so the 20 is going to go on top. And what was the adjacent? Yay, we've written our own trig equation. Now we take it back to 4 problems ago, and now this becomes like the one that we did. But wait, there's more. Huh? What's different about this one and the first one that we solved that was already written for us? There's learning going on. Oh, Fuzzy? Yeah, the variable is on top. Now the variable that we're looking for is on the bottom, which I can make this be real mathy. I can show you how this is a proportion and write it as a proportion and cross multiply, and we can get more detailed, but then more confusing. Or I can show you a shortcut. Take the shortcut. Okay, but shortcuts sometimes require listening. So okay, if regardless of what the trig function is, I don't care if you're using sine, cosine, tangent, whatever it is. If what you're looking for is a side, Natalie, and that side is on the bottom, what operation did we do the last time? When it was on the top that we were looking for? what operation did we end up using the first time? We did multiplication. Well, when it's on the bottom, you're going to use division. Which, what are we going to divide? It's real simple. Just get the variable and flip-flop it with what's on the other side. So now, instead of writing tan 30 equals, I'm going to write A equals, which is what I wanted. I wanted to know what A was. I'm still going to write the 20 on top, but then I'll write tan 30 on the bottom. Instead of multiplying, we're going to divide. What are we going to divide? 20 divided by tan 30, as long as the calculator says degrees. You should get somewhere around 35, but if Jair said 34 point something, and Jair we trust. 34.68 you said? 0.644. Alright, so around, yeah, they rounded to the nearest whole number, but we'll just go 34.6. Usually they'll tell you where to round to. In a right triangle. I mean, you actually could use it to find in any angle, but we don't do that here. That's called the law of sines and law of cosines. But we don't. Okay. So that's not a bad question. If we know trigonometry, do we have to know special right triangles? That we know. Anything that can be done with special right triangles can be done with trig. The difference between the two is that special right triangles allows you to remain exact. You can precisely solve, whereas in many cases, trig is going to force you to round. Let's think about it. What did you, even with special right triangles, what did you end up with a lot of? Square roots. Now, if you got a fancy smashy calculator like Wyatt does, then yeah, it'll even with trig, it'll give it to you with the square root. If it happens to be a special, if it happens to be a 30 or 45 or 60, now you're going to be suffering anyways. But that's the main difference. Learn special right triangles. No, we did not learn. But yes, special right triangles derives from trig. Yes. Where did I get the 30 from? No, that's the answer. Like a lot of these, I copy from teachers' editions. So like that's not part of the problem. That's just the answer. Like that's why it's a different color. That's why it's red. Scratch it off for me if you want. I didn't get the 35. They got the 35. I got 34.2. I'm not making sense? There you go. It's not part of the problem. You want me to draw your nose? No, you actually won't. You haven't. Okay. Yes, Natalie. Because Muhammad wanted to. And when you cannot bring Muhammad to the problem, we bring the problem to Muhammad. So the question was, on this last one, why did we switch the two? And the reason why is because it's really a shortcut. So any attempt to explain why would involve me having to show you exactly mathematically how to isolate A. Okay, but what I tried to do to keep it simple, and Bazik picked up on, is that the A was on the bottom. When the variable you're looking for is on the bottom, the easy way to get it by itself is to switch it with the tan 30. On the very first equation that we did, where they had written already for us, the variable that we were looking for was on the top. So the shortcut there was just to get the number on the bottom and move it. Let's write another trig equation. Shaylee. You can even pretend it is not even here. That's not part of the problem. So we're going to write our own trig equation. The one thing we know for sure is that we're going to use 65 as the angle. Yep. We don't know the trig function yet, We do know the sides. The sides are going to be B and 17, but I don't know where to put the sides. That's going to depend on where the sides are located. So relative to where the 65 is located, what side is that B? You have three options. You have a 30, even if you were to guess, you have a 33% chance of guessing right. That is the opposite leg. Very good. What is the 17? It's the hypotenuse. It's crossing the 90. So even though it's touching the 65, it is not a leg. It's the hypotenuse. So then the question is, Jair, what trig function relates opposite with hypotenuse? Yeah. Opposite with hypotenuse. So sine and sine. So Shaylee, that means I put sine in front. And then now that I know that I'm using sine, that's when I need to figure out where to put the B and the 17. Because sine is specifically opposite over hypotenuse, the opposite has to go on top. What did we say was the opposite? B, and then that, and dollars. So Natalie, even though I might be using, I don't even know what we did before, it doesn't matter what trig function we're using, the fact is that the variable that we're looking for is a side, and that side is located on the top. The operation, therefore, that I'm going to end up doing is multiplication. Unlike the last time we did division, we're going to multiply. And the easy way to multiply, the easy way I gave you to go ahead and isolate the variable already, is to get the bottom and just move to the front. So that B is going to be exactly equal to 17 sine 65. But then, yeah, then they're going to ask you to leave it that way unless it's specifically. If they tell you to stay exact, that is the most exact that we can get. But they're not. They're going to ask you to round. So put that in the calculator and let's round it. 15.4 something? 15.40? Okay, 4-1. Take that, Scotty. You're not the only calculator in town anymore, Scotty. And then Shady, then the big reveal. When I show off what the answer that was there already, they just rounded differently. They rounded to the nearest whole number, but you see we got it right. So when we come back from Turkey Day, nice. When we come back from Turkey Day, we have one more day where we're gonna finish the notes before we move on. You like trig now? Most of the stuff isn't bad if you pay attention. You'd be surprised.